Let's start our session. Good afternoon, distinguished participants from Indonesia and Korea. Can you hear me?
Yes.
Yes.
Okay, that's good.
Yes,
Good.
thank you.
So
It's clear.
our session is for water management challenges and opportunities in the Citarum Basin, Indonesia. And I'm Go-Hee Kwan from Ocean Engineering, the chair of this session. So I'm very happy to meet all of you and to discuss about our Citarum together this afternoon. In our session, we are inviting two valuable speakers, one gentleman from Indonesia, one gentleman from Korea, Dr. Imam Santoso. He will provide us a keynote speech, and Professor Kim Beomcheol, he will introduce useful case study regarding fish farm issues in Korea. Also, we have invited 5 panelists in our session, Professor and Dr. Eko Binari-Irianto from Beomcheol, and Pak Abdul Malik from Apenas, and Professor Robert Treco from Parahyangan Catholic University, and Dr. Hong Il-pyo from KICT Korea, and Professor Jung Se-hong from Chungbuk University, International University in Korea. Actually, Mr. Eric Pinchot from Asian Development Bank, he was planned to join us, but he had another big sudden task, so he cannot join us this afternoon. And the other one, Dr. Park Sang-young from K-Water. Now he is in Senegal, Africa, for another mission, so he cannot join, I'm afraid. But anyhow, we have 2 speakers and 5 panelists. First, I'd like to introduce Dr. Imam Santoso first, our keynote speaker. Dr. Imam Santoso graduated from Civil Engineering Department of University of Gajah Mada. In Indonesian language, they say UGM, and he had his master's degree study from United Kingdom, and doctoral degree from the University of Nippon Gonoro. Sure, Jaji.
Ngobrol jangan ya. Ngobrol so.
Okay. And before he joined this Perum Jasa Tirta 2 last year, he has spent most of his time in Beomcheol, the Ministry of Public Works and Public Housing. So he worked a lot for the director of Rive and Coastal, and as the head of Dam Construction Center, and finally, Director General of Water Resources in the Ministry of Public Works and Housing. And now I'd like to invite Dr. Imam Santoso to present his keynote speech. Let me insert his presentation materials. Okay, now you are ready.
Okay. Can everybody show my file? Okay.
Yeah. We can see your slide.
It's radio, please.
Okay. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum.
Assalamualaikum warahmatullahi wabarakatuh.
The International Session Chair, Dr. Go-Hee Kwan, as the Vice President of Ocean Engineering Corporation, all panelists, all of my friends, Professor Dr. Eko, Dr. Abdul Malik,
Thank you very
Professor
much.
Robert, and Dr. Song and Professor Chung. Also, the speakers, Professor Kim, all distinguished ladies and gentlemen. all participants. It is my great pleasure to be here at 2021 Session Global Water Forum. Please do allow me to convey my warmest regards to all of you, including the host of this wonderful event. Ladies and gentlemen, looking at into the current situation of the water resources potential, Indonesia belongs to the third richest countries in the world in the term of total renewable water resources. The total available fresh water for the country reaches about 3.9 billion cubic meters. If we focus more on the fresh water per capita, Indonesia is ranked 42 worldwide. It means if the government is able to well manage this great resource, it offers a huge opportunity to enhance the sustainable development. When we see of the Indonesian water resources from 3.9 billion cubic meters per year, the water availability that can be utilized in Indonesia is only 690 billion cubic meters per year, which is a lot more than the demand of 175 billion cubic meter per year. Papua and Kalimantan in Indonesia, which has only 13% of the total population in Indonesia, has about 70% of the water sources. On the other hand, availability water in Java is only 4%, whereas it is known as the most populated island in Indonesia. Based on the United Nations water, UN water, in 2019, problem takes related to water have a major impact on human life. Whether it is the problem of clean water supply and sanitation, drought, or flooding. This shows how important water is for life. Improper water management can have a very large and detrimental impact on humans, even exceeding the impact of earthquakes and community conflicts. Unfortunately, nowadays, we also have a pandemic of COVID-19, as well as we know, has put a strong impact to the global disaster of many countries, including Indonesia. It's also impact the water resources in Indonesia. Allow me to explain the glance about Jatiluhur multi-purpose reservoir in Citarum River Basin. The Citarum River Basin is covering an area of about 12,000 square kilometers with the overall annual flow of 12.9 billion cubic meters. By employing water resources structures in basin, the water that could be regulated is about 7.6 billion cubic meters per annum, and the rest is wasted flow to the sea. The utilization of water by far goes to irrigation is about 88%, and for the domestic and municipals and industry is about 12%. You can see the map of the Citarum River Basin as in the screen. If we're talking about the Jatiluhur itself, it's the Jatiluhur is built in 1959 and 1957 until 1967, and the first name is in 1970. The name is Forum Otorita Jatiluhur. But in 1999, it changed to become Perum Jasa Tirta II. In Citarum River, there are two also Saguling Dam, which is operated in 1986, and Cirata Dam operated in 1988. All reservoir in Citarum River Basin are named Citarum Cascade Dams, and it is managed by three different operators. One is by Perum Jasa Tirta II, and the other is by PLN. With the different goals, this Cascade Dam, it becomes complex, challenging in managing the Citarum River Basin. Our task is use of the water reservoir for business activities. Is we are supply for the raw water in nearly 1.1 billion cubic meters per year. Also, we have a business about hydroelectric power plant with amount of 187.5 megawatts. We also have a drinking water supply, especially for Jakarta and other provinces and other regions in West Java. Also, we have a laboratorium services. And to implementing of the water resources, we have the management tax for the water of irrigation, 300,000 hectares. For conservation, also for flood control in the north of the West Java. And also we make operation and maintenance of water infrastructures. Ladies and gentlemen, there are several achievements and benefits of water resources management done by the Perum Jasa Tirta II, such as first is we are support the national food security through the provision of 4.6 billion cubic meters per year irrigation water for an area of 300,000 hectares in the northern part of West Java. We also have a tax for flood control in the north of West Java and Bandung region through the water level control in 3 reservoirs. This is Saguling Dams, Cirata Dams, and Haji Juanda Dams, or we call it Jatiluhur Dams. For the supporting for the national energy security, we also do with through the provision of 5 million kilowatt hours per year, using the raw water for hydropower in Saguling, Cirata, and Jatiluhur. We also support the resilience of water resources infrastructure function through operation and maintenance activities of 100 billion rupiahs every year in Citarum River Basin. To support the water shed carrying capacity, also through the conservation of the upstream
Nggak ada ya Pak, ininya dokumennya.
activities.
Kemarin terakhir di mana ya?
Sorry, this is the Jatiluhur dams also support the drinking water and industrial security for capital city Jakarta and several regions in West Java through securing raw water supply of 1.1 million cubic meters per year. If we're talking about the water management in Citarum River Basin, we have a total discharge 13 billion cubic meter per year, and for 62%, it is about 8 billion cubic meters per year is a regulated flow, and the rest is the unregulated. From the 8 billion cubic meters we use for the irrigation is 90%, and 10% is used for municipal and industrial business. If you're talking about the Jatiluhur irrigation system, it starts from Jatiluhur Reservoir, then divided at Curug Weir at the West Tarum Canal, transferring several rivers up to Ciliwung, then to the north Tarum Canal, and to the east Tarum Canal up to Cilalanang River. The Jatiluhur irrigation network scheme can be described as follows. The potential available water is in a year is about 12.9 billion cubic meters, which is 6 billion cubic meters is from the Citarum River, and the other is from the 9 other rivers. The water is enough to provide 20% of rice cropping intensity, or some part it can be up to third cropping season. This area is the largest irrigation system in Indonesia. It is a major rice production area, about 300,000 hectares. Furthermore, I would like to talk about the opportunity of the Jatiluhur for the proposed reservoir. Forum Jasa Tirta II also have a role to involve in the food security by implementing of SIMOP, or we call it strategic irrigation modernization and urgent rehabilitation project. First, we done it by water allocation from the dam, and second by operation and maintenance of main and auxiliary infrastructure, main and secondary canals, and then the development of water resources information system to support operation in irrigation area. Also, we do the real-time monitoring of water distribution by utilizing telemetry such as water level, rainfall, weather, and water quality sensor. Also, we empowerment of water user farmer association. For better management, applying by Forum Jasa Tirta II, it is very important in the sustainable management of water resources to optimizing by utilizing information technology. Forum Jasa Tirta II is committed to continuing to develop the water resources information system, or we call it in Bahasa SISDA, by adopting technological development in the 4.0 industrial era. It was started and supported through a collaboration with Key Water in 2019 until now. So we still hope the collaboration is still going on, and for the now until the future, to make ICT integrated water resources management system, such as sectoral water management, integrated water sector planning, climate change adaptation, disaster risk reduction, reporting, specific decision taking, and others activities. In SISDA, in Forum Jasa Tirta II, continues to be developed with the application of the latest technology towards SISDA, with the best UI or UX design to accommodate systems that are increasingly dynamic, flexible, multi-device, easy implemented by collaborative system. This is we are done now in Jatiluhur or Waduk Juanda, to keep monitoring of the behavior of the reservoir, also the rainfall, and also all the systems. And also we continued to develop with the application of the latest technology toward with the best mobile application system. And then we can the several data that can be viewed, such as discharge, water level, infrastructure condition, and others data. So it is easy for us to see from the mobile phone. I would like to talk about the impact of floating net, or we call it KIDS, or we call it Karamba Jaring Apung, on water quality in Jasa Tirta II. The research in 2019 saw that the high DO value of 4 until 6 ppm is a high nitrogen and phosphorus levels, which cause the water quality is heavy populated. Existence of the KGA or float net cage in Jatiluhur is seriously threat, because when the waste of the fish feed reach 30%, the sedimentation due to the feed was reaches about 82,800 tons per year. Another impact of the KGA is the invasion of the foreign specific that can change the structure of the original fish. It makes the loss of the native fish population. The others impact the water quality degradation is also a factor that has bad impact to hydroelectric power equipment, to damage or make a phase correction of the machine or turbine. It means to reduce the lifetime and increase the maintenance time and cost and reduce the operational hours. From these photos, you can see that this a lot of floating net cage in Jatiluhur Reservoir. It seems that nearly 30% is noise about more than 40,000 cage in this area. This photo is this is situation now in Jatiluhur Reservoir. A lot of floating net cage. But we also have monitoring equipment. There are 16 monitoring points with each location has a different depth. The total 37 samples collected every month. And I will show you after this the result of this monitoring quality control in Jatiluhur. From January to July 2020, it is shown that the water quality in Jatiluhur Reservoir is mostly medium polluted and several locations heavy polluted. This is far below the standard. This last 3 months before, so we can see this is the graphic, so that the quality in the water quality in Jatiluhur is below the standard. We have a leaders commitment to protect the Citarum watershed rehabilitation. The president of President Jokowi said that in the middle of January 2018, we will start of Citarum watershed rehabilitation from the upstream to the downstream, because accordingly to the data, the water of Citarum River has shown decrease in quality. And the coordinating Ministry of Maritime Investment Affairs, Mr. Luhut, also have a task as a head of steering committee of Citarum Watershed Task Force. And the governor, Mr. Ridwan Kamil, said that the main problem and the poor water quality is because of the solid waste, industrial wastewater, and domestic wastewaters. So this is the commitment is not only in the reservoir, but also in all part of the Citarum River Basin. So they have commitment to make clean water in Citarum. As we know that the Citarum is famous about the very dirty rivers in the world. So the government's now trying to make it clear and at least make it safe and healthy. This is the action plan for Citarum Harum. We call it Citarum Harum, to control the fish farm, to make a better quality of the reservoir water. Including the data collection in 2021, the number of fish cages is 46,000 cages. This belongs to the 3,500 farmers. And we have the regulation, which is by West Java Governors number 28 in 2019, and also revised into number 37 in 2021. It shows that only 11 number of fish cages can be allowed in this area. But up to now, because of the several constraints such as lack of funding in handling floating net catch reduction, developing of environmentally friendly marine catch technology, or lack of transfer business option from fish farming into the other livelihood. Also, law enforcement. I hope that in the explanation about from Dr. Kim, Professor Kim, about the Korea experience in reflowing fish farm issues in the lake Soyang in Han River, maybe can make us idea how to make it the Citarum, the quality, water quality in Jatiluhur is become better. From this government's goal from Citarum Harum, they have a plan that in 2030 is become a water class quality. As I said before, the baseline is in 2018 when the president of Jokowi stated that the quality of Citarum have to be improved. In 2018, they are heavy populated with a point of 30 point, and up to now they have the 7 years program to make it clear, and in 2020 is become increase and improvement on the water quality is now become lightly populated on have 55 points. The ultimate goal is on 2025 that the target is become water quality with the class 2 with a have a point of 60, and also in the next or the future we hope that it's become 17 point. Talking about Jatiluhur 2, I will back to the Jatiluhur 2. We are a company, government company, which is also have thinking about the benefit. So in the future development, we have to make some other business beside water. So we try to have in the next future to develop of the renewable energy, and we know we at the moment have the minute of understanding with the Danareksa and Vena Energy and India Karya to develop a solar and wind farm. It's about generate to 200 megawatts in Babelan, and also in the for the Jatiluhur floating solar or floating photovoltaic, we will develop 4 times 100 megawatts or 400 megawatts in Jatiluhur, and now we have a minute of understanding that with the several investors in Jatiluhur, and also for the pump storage power plant, we have a minute of understanding to develop 4 times 190 megawatts, or is about 760 megawatts with Indonesia Power and Sino Hydro. To develop of the drinking water supply system as a government company, we also try to have the business on the drinking water supply in Pamanukan with a capacity of 300 liter per second. Also in in Pertamina in Batimban. Also in Bandung City with 3 cubic meters per second, and also in we try now to have operation and maintenance of the pump in Batam Island. For the closing remarks, before I am going to closing remark, I would like to inform you that today in this morning, we have official visit. That's why I want to because I have the coalition with the Korea. So the Ministry of Ocean and Fishery, the Republic of Korea, Professor Dr. Moon Sun-hook, come to us in Jatiluhur today, this morning, to see the site visit together with the Governor of West Java, Mr. Ridwan Kamil, and we discussed about several collaboration, how to make manage the Citarum River Basin and make some building capacity in this area to make a better life quality and water quality in this area. Ladies and gentlemen, this is there are photo today. I'll take it today and put this in this presentation. So this is the update status of today. And for the closing remark, I would like to have first the collaboration improvement between organization, not only on national but also international, could enhance water resources management, such as international cooperation with Korea in terms of further promoting proactive IWRM for Citarum River Basin. Today, the ministry is coming here, fishery, and we also talk about the collaboration. And for the closing remark, for the second, the implementation of information and communication technology, ICT, that is suitable and applicable would alleviate operation in managing water resources. Now the key water is already give us some transfer of knowledge in the ICT, and we hope that in the future this collaboration is still going on also with another agency in Korea. So we have knowledge and technology. The human resources development or capacity building is an asset improvement, such as tech knowledge transfer and expert enhance with the international agencies. So we hope that the Koreans agency in Koreans can have exchange in knowledge to how to treat the better quality water quality in Jatiluhur reservoir. Like today, that Mr. Kim, Professor Kim, will have a presentation about fish farm issues, and we hope that this knowledge can be used in by us in Jatiluhur reservoir. Also, the investment in the new infrastructure could generate more options for water, food, and energy securities. The last, we have not progressed about the global change is inevitable and should be addressed accordingly. Ladies and gentlemen, thank you very much for your attention. And this is all my presentation. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Imam, for your excellent and valuable keynote speech for all of us. So to save time, I will not re-summarize your speech, and let's move on to introduce our second speaker, and then we'll continue for panel discussion. So our second speaker is Professor Kim Beomcheol at the Gangwon National University in Korea. Professor Kim is the president of Korean Society of Immunology, and now he's an emeritus professor in Gangwon National University, and he has his bachelor degree study at Seoul National University and master degree study at IC in Korea, and doctoral degree again in Seoul National University. He has a lot of research and teaching experience in the field of limnology, water quality management in streams and lakes, and freshwater ecology in Korea. So it must be quite exciting to share his experience regarding fish farms problem solution at Lake Soyang in Korea by sharing with all of Indonesian water expert in this afternoon session. Please, Dr. Beomcheol, it's yours.
Okay, can you hear me? Okay. Okay, I'm glad to have an opportunity to share my experience in reservoirs in Korea. First, I will introduce Lake Soyang, which is my major research site. Okay. Okay, Lake Soyang is the largest reservoir in Korea and deepest in Korea. Maximum depth is 100 meters. Major environmental issues in the reservoir was fish farm establishment and during 1990s. And finally, we removed all fish farms in 1999. And recently, non-point source pollution from agricultural field, it has been environmental issues. Briefly, I summarize the history of events in Lake Soyang. It was made in 1974 and fish farms were established in 1980s. And after several years, we could see cyanobacterial blooms of Anabena. The first appeared in 1986, and it flourished in 1990s during high production of fish. And in 1999, finally, we removed all fish farms in this reservoir. And after 1 year, we could see a very quick recovery of water quality. So we could see very clear water. You could see the photo of Anabena cyanobacterial blooms. It looks green. Okay, this figure shows the long-term change of water quality, especially chlorophyll A quantities, the density of phytoplankton, which was high in 1990 and 1995, 96, during the period of high aquatic aquaculture production. Fish farms were very important, a major source of phosphorus. In the net cage type fish farms, fish excrete, and the excretion can be dispersed directly into lake surface, causing cyanobacterial blooms and anoxic hypolimnion in this reservoir. Or actually, we had many fish farms in all major reservoirs in Korea. I'm focusing on the importance of phosphorus because phosphorus is the major limiting factor, controlling factor of eutrophication and cyanobacterial growth. This is the scatter plot of phytoplankton density versus total phosphorus concentration. It shows very strong positive correlation, which means phosphorus is the key factor controlling eutrophication and algal density. Why eutrophication? Why is eutrophication harmful? First, toxic cyanobacterial blooms occur in eutrophic lakes. Cyanobacterial toxin is very toxic and very harmful to humans, to fish, and many aquatic animals and many mammals. It reduces biodiversity And second, it can cause anoxic hypolimnion. I think you can see hypolimnion and becomes anoxic in your reservoirs. Anoxic hypolimnion can kill many fish, especially on windy day. Anoxic hypolimnion water can be dispersed to the surface and can kill fish. And it can reduce local fisheries harvest. So it can give very big economical cost. And third, it deteriorates drinking water quality. In eutrophic lakes, you can have increase of water treatment cost in the water supply treatment plants. And even after treatment, you can have odor and taste problems in tap water. And also we have more carcinogen in tap water. Then what are major sources of phosphorus in the environment? First one is animal manure and compost made of manure. Animal manure contains phosphorus, always it contains phosphorus. And phosphorus remains in the compost even after a long period of composting. And the second, sewage contains human excretion. And third is chemical fertilizer. They are in inorganic forms, and it can infiltrate into soils and combine with soil. Which are how much this table shows national phosphorus budget in Korea. It shows chemical fertilizer occupies 41% of annual phosphorus use. Animal feed or compost, including compost, occupies 36%, and human use is only 20%. And both fish and cattle, chicken, and pigs can excrete phosphorus. But if we compare phosphorus excretion by fish and by other cattle and chicken, phosphorus excretion by fish is more harmful. Usually, phosphorus in the agricultural field is absorbed onto soil surface. Soil can absorb phosphorus very effectively. So usually only 5% of phosphorus applied onto agricultural field is exported to streams or lakes. Once I measured phosphorus budget in a very high slope agricultural field, we calculated all input amount of phosphorus and output discharge out of the watershed. We could see 10% of phosphorus is exported out of watershed. This was the case of very high slope area. So if you measure it in the flat land, maybe 5%, less, only 5% can be exported out of a watershed. So when we compare the impact of phosphorus from compost fertilizer and fish farms, impact is much bigger. Because the phosphorus in fertilizer can be absorbed onto topsoils and retained in soil. So only 5 to 10% of phosphorus can be exported out of watershed. But in case of fish farms, directly fish excrete into water, into lake surface. So phosphorus is more available than same amount of phosphorus used in terrestrial agricultural field. This figure shows the primary productivity of phytoplankton in Lake Soyang and the amount of aquaculture production. you can see a very high correlation between aquaculture production amount and primary productivity of phytoplankton. Black dots aquaculture production, it goes to 0 at the year 2000. All fish farms were removed in 1999, and in 2000 year, we could see very quick recovery of water quality and reduction of primary productivity by phytoplankton. So it shows that the impact of aquaculture was very great in this lake. Then how can we control fish farms, or how can we control the impact of fish farm? I will shortly, briefly introduce what we did, what we thought to control fish farm impact in Korea. The first one was to restrict total number of cages and dimensions of fish farms. And the second is to reduce phosphorus content in fish feed. And third, we tried to improve feed quality, fish feed quality, to improve absorption by fish or digestion by fish. And the fourth, finally, we removed all floating net cage fish farms in Korean reservoirs. And for the last fifth, I can suggest another alternative method. Okay, First, we tried to reduce the number of fish farms or production of fish farms. So Korean government established a license law for fish farms, and we issued licenses to fish farms by 10-year terms. Actually, after 10-year terms in 1999, we didn't extended expiration. We didn't extended the license. So in case of Lake Soyang, the number of fish farms licensed was 13 in Lake Soyang, and 33 farms were licensed in Lake Chungju, like that. So we issued the limited number of license to fish farms. And also the total number of cage was restricted. Unit size was 5 meter by 5 meter. Total number was limited for each reservoir. So usually the limited total number of cage was several hundred per reservoir. But even if the number of license was restricted, but we couldn't control the feed amount of feed they use. So in the same number of cages, they could produce more fish. But if we have a higher density of fish, we could have higher probability of fish disease. Anyway, we couldn't control feed amount of feed application. And the second, we tried to phosphorus content in fish feed, because phosphorus is the key factor of eutrophication. If we have more phosphorus in fish feed, fish can excrete more phosphorus into water. At first, phosphorus content of fish feed regulation was over 1.8%. Yeah. So we requested higher phosphorus concentration in the fish feed at first, because with the higher phosphorus content, we can produce better quality of fish meat. But later, in order to reduce phosphorus excretion, we amended the feed regulation to phosphorus content below 1.5%. Yeah. It was over 1.8%, but now we changed it into below 1.5%. By this change of regulation, we could reduce about the phosphorus loading into about 50%, about half of phosphorus loading was reduced by just this regulation. So it was very effective. And we also tried to improve fish feed quality, because fish feed can contain a lot of non-digestible ingredient, especially when we use low quality fish feed. A lot of ingredients is not digested, not assimilated by fish, and it is just excreted out of fish. So by improving the feed quality and digestibility, more ingredient, more feed is digested and assimilated by fish, and less amount of phosphorus is excreted. But problem is that it costs, with better quality of fish feed, it costs a higher price. So actually, it was not easy to control the quality of fish feed. So it was not adopted by many fish farmers, and I think it was not effective to reduce phosphorus loadings. So finally, after 10 years of struggling and many controversies and debates, finally we decided to remove all fish farms from Lake Soyang and actually all Korean reservoirs. Before 1999, there were many floating net fish farms in all over the Korean reservoirs, but after the expiration of their license, we didn't extend license, and all fish farms were removed in 1999. And after that, water quality recovered very quickly. So just after 1 year, we could see cyanobacterial blooms were decreased, and chlorophyll density decreased, and water clarity, transparency increased. Yeah. So that was our final solution. But there is another alternative method. If you can't remove all fish farms, we can have another alternative method, which is alum treatment. Alum is aluminum sulfate, which is used in water supply treatment plants. When we make tap water, we use aluminum sulfate or aluminum chloride to precipitate particles in the water. It can be applied to lakes, and aluminum can combine with phosphorus, and it can reduce cyanobacterial blooms. Actually, this method, alum treatment method, is not an innovative method. It is a 50 years old traditional method, which is very commonly used in United States. But in Korea, this method was not adopted because many people were reluctant to using chemicals in water supply resources, reservoirs. I briefly introduced phosphorus inactivation by alum. Aluminum can combine with phosphate, and it can settle down to the bottom. And aluminum hydroxide can precipitate to the bottom of the lake, and it can cover a sediment surface. At the sediment surface, it can block the regeneration of phosphorus from sediment. Usually, organic matter can settle down to the bottom of lakes, and at the sediment surface, they are regenerated, and phosphorus can resolve into overlying water. But aluminum hydroxide can block the release of phosphorus from the sediment. So this method is quite effective, very effective, and environmentally safe. Aluminum is not toxic, so it has been used for water treatment for about 100 years. And the cost is economical, just 1 cent per ton of lake water. This is the official recommendation and document of North American Lake Management Society. They recommend strongly the use of alum for lake management, especially if you have cyanobacterial blooms, which is very harmful to human and to ecosystem. They recommend to use alum. Okay, and this is a brief introduction of fish farm issue in Indonesia. It was an article by Arianto Santoso, who is here. He briefly introduced the floating cage aquaculture problems in Indonesian lakes and reservoirs, and it causes, he said, it causes eutrophication problems. And he sent several photos. You can see in this photo small dots, cage of fish farms. And the number of fish cage farm is very, very large compared with the Korean case of Korea. Okay, finally, I'd like to give my opinion about the cost and benefit of aquaculture if in water resources reservoir or water resources lake. If we calculate environmental impact of eutrophication, phosphorus removal cost from sewage usually is $1 per 1 gram of phosphorus removal. But if we discharge 1 gram of phosphorus from aquaculture, 1 gram of phosphorus means 50 grams of fish feed, which can produce less than 100 grams of fish. The price of 100 gram fish can be much lower than $0.5. So if you compare economical value of environmental impact of better water and more fish, it is not economical to grow fish in your water supply resources. Okay, that's my opinion. Thank you very much for your attention.
Thank you, Professor Kim Bong-chul. So best experience and the solution by Korean water and environmental experts government. So maybe we can, if it is necessary, we can continue, we can develop some joint research project for Citarum, and maybe we can work together after this session. We can make, I think that's another good possibility, I hope. And next, let's move on to our panel discussion. We have 5 invited panels, but luckily, 3 panelists from Indonesia, they prepared the PowerPoint presentation file for their special comment. So I'd like Professor and Dr. Eko Irianto, would you like your presentation file for your comment, and then you're welcome.
Yeah.
Okay.
Yeah. Okay. Yeah. Thank you, Dr. Ko, and audience. Thank you very much for your. Okay. I start the presentation. Yeah. Please for share the screen. Yeah. Okay. Yeah, it is clear for you to get this information. Okay. I will inform about the water management challenge and opportunity in Citarum River basins. Yeah. So next, yeah. Citarum River Basin is based on the Ministry of Public Works and Housing number 4, 2015. The general data is number of watersheds in Citarum River is 19, and the Citarum River length 297. Upstream, in the upstreams there is a Cisanti Lake, yeah, and the downstream is the north coast of Java Island, and the Citarum also through the 12 regency and cities. So the river area or the catchment area of the Citarum River is around 11,000 kilometer squares. It's around 32% of West Java province. Okay. The utilization, the general utilization of the Citarum River is now as hydropower turbines drive for Java and Bali energy, and also raw and industrial water supply, irrigating the irrigation area, which is the national rice granary, and the main source of raw water for the national capital. This is the river basins of the Citarum. This is around based on the decree of Ministry of PUPR number 4, years 2015. Yeah. Okay. This is the water management challenge in the river and the Citarum River basins. So we can see the complexity of Citarum watersheds problems, such like problems flooding, of course, and critical land, and also land use change, and the water pollution problem, and also erosion and sedimentation, and also now we know about the land subsidence in the spots of the Citarum River basins. And this is a map, the graph of the Citarum watershed problem. It starts from Cisanti Lake. This is upper Citarum, and Saguling, Cirata, and Jatiluhur reservoirs is in the middle Citarum, and then this is area of the lower Citarum. Okay, and then this is the implementation plan of the presidential regulation number 15 at 2018. In the upper parts of the Citarum, the problem is the land clearing, the sedimentation, flood and livestock waste, domestic waste, industrial waste, and sometimes medical waste. The agency support to handle the situation in the upper part of Citarum is the Ministry of Public Works and Housing, Ministry of Agriculture, Ministry of Health, Ministry of Industry, Ministry of Environment and Forestry, and Ministry of Agrarian and Spatial Planning. While in the middle part of Citarum is the, of course, is the sedimentation problem, and also fish catch in 3 reservoirs, and also sometimes in there is heavy metals and E. coli problem, mainly in the Saguling reservoir. However, the agency support to handle the situation, of course, the Ministry of Industry, Ministry of Environment and Forestry, Marine and Fisheries Ministry, Ministry of Agrarian and Spatial Planning, Ministry of Energy and Mineral Resources, Ministry for Public Works and Human Settlements, and Ministry of Health. Then the lower the lower part of Citarum is the problem are industrial waste, household waste, sedimentation, and also mangrove destructions, and also flood and medical waste. Then the agency support to handle this problem is the Ministry of Agriculture, Ministry of Environment and Forestry, Ministry of Industry, Ministry of Maritime Affairs and Fisheries, and also Ministry of Health. So this is the national strategic issues that we know about that we happened in the Citarum River. Yeah, of course, clean water supply targets. Clean water supply target. The urban national targets we hope in 2030 is 100%. Yeah, of course, we have to efforts the allocating raw water from springs, rivers, lakes, and existing potential dams. And then the energy sustainability. The national electric demands 2015 is around 51 megawatts, while the West Java electric demand, yeah, is 71 megawatts, or around 8,000, yeah, 8,000 megawatts. And also in the existing or PLT or the Saguling Dam from Saguling Dams around 750 megawatt, Cirata Dam around 1,000 megawatts, and Jatiluhur Dam around 187 megawatts. So the total is 1,937 megawatts. Yeah, the power generation from water resources has not been intensively cultivated. And then the national strategy is water sustainability. The water potential in the Citarum River Basin is around almost 13 billion cubic meter per year, and 7.65 billion cubic meter per year can be controlled, or this the 86.7% this for irrigation, 6% for raw water, and 2% for industry, 0.3% for municipal, and 5% for maintenance. And then the remaining is the 5.3 billion cubic per year cannot be controlled or wasted into the sea. So the river restorations should have been repairing river infrastructures and also reviving the exposed by opening embankments and reviving the dead rivers, widening the river borders. And then the food sustainability. West Java rice production is around 11 million tons, or 31.6% of Java total production, and 50% of 50.41% of Indonesian total production, around 75 million tons. While the irrigation area in Citarum River Basin is around 353,000 hectares, then the central authority 271,000 hectares, the province 32,000 hectares, and the regency or city is around 49,000 hectares. And so this is can be divided that 40.5% of irrigation area in West Java province, around the 871,364 hectares. The planning to increase irrigation area is around 600 hectares is carried out by constructing the Sadawarna Dam. While the other national strategic issue is the global warming and climate change. The trend of the increased temperature is quite consistent. It is estimated that there has been 0.8 degrees Celsius increase the temperature in the last 50 years. This is based on the Ministry of Environment and Forestry 2015. Rainfall in the rainy season slightly increased between 1 till 5%, while the dry season's rains tended to fall between 5% till to 20% from today. Yeah. Okay. This is based also from the Ministry of Environment and Forestry. Yeah. The other strategic issue is the local strategic issue. We can see the land use change. The increase in residential land from 2001 until 2014 amounted to 122,000 hectares, or around 10.86% of the total area of river basins. And also the critical lands, the area of critical lands, somewhat critical, and somewhat critical, and very critical in the Citarum River Basin is around 431,000 hectares, or 38.1% of the total area of the river basin. While the local strategic issue, also the river pollution. The river pollution is around 60% of household waste. 30% is liquid chemical industry, and 10% is the agricultural and livestock waste. The volume of waste in the upstream area of the Citarum River, which is around Bandung Regency, has reached 500,000 cubic meter per year. Then the annual floods occur in the upper Citarum area. Now is around 750 hectares. In the Muara Gembong area, is in the estuary, is around 180 hectares, and the Pantura area, Pantura is mean Pantai Utara Jawa, it's northern coast of the Java, is around 11,000 hectares. Nah, so there is also the water resources information system problems. The problem of water resources information. There is still a lack of equipment and water resources information data, which includes proportional hydrological, hydrometric, hydrological, and hydroclimatological data throughout the Citarum River Basin. So it is necessary to increase the human resources who handle natural resources data and information. So there is no coordination between agencies managing data and information on natural resources in the Citarum River Basin. There are no guidelines on integrated natural resources data management and information system. So forecasting system is still a lack of data, such as a supporting data from BMKG, and an increase the capability of operator is needed. So the manual book for repairing equipment in the field lacks detail. In the manual, only general things are explained. Now, this is the flooding problems in Citarum River basins. The cause of flooding, the intensity intensity and duration of rainfall, the last 20 years of rainfall, which the intensity below average rainfall can cause flooding, the possibility of climate change causing big rainfall intensity in a short duration, the influence of local conditions, changes in watershed characteristics, such as the land use change that cause land to become critical. So sedimentation reduces the capacity of the river. Okay, this is information about the flooding in 1986 until 2014, because there is the reduce of the flooding, the flooding because of the improvement of the river capacity. Yeah. This is also information about the land use change of Citarum River. So this is a comparison between Citarum River Basin at 2002 and Citarum River Basin at the 2012. Yeah. Yeah, okay, the land use map of Citarum River Basin. This is the settlement in expansion. This is very high in the upper Citarum River. Yeah, nearly. This is the Bandung area. Is the intensive change of the land use change. Yeah. Okay, and then this is information of critical lands. The critical land area of the Citarum River is around Citarum River Basin is around 4,314 kilometers squares. Somewhat critical, critical and very critical, or 38.1% of the river basins. The critical land area on the Citarum River watershed is around 262 kilometers square, resulting in the runoff surface flow of around 3,000 million cubic meter per year and sedimentation of around 7,800 tons per hectare. So there is a very high. This is information about the critical land in the Citarum watersheds. This is the farmer is preparation of vegetables. Yeah. And this is the location of the water pollution area. The Citarum watershed critical water pollution. Critical water pollution from upstream, yeah, from upstream. This is Bandung, Cimahi, Sumedang, to the downstream of Purwakarta, Karawang, and Bekasi, where there are many scattered industry that contribute waste to the Citarum River. This is an evaluation of environmental management performance by the industry in Citarum watersheds. Yeah, as this now the graph, there are many regional industry sector that have not been obedient in environmental management. Okay, this is information also about the water pollution, about the domestic waste in Citarum River. This is we know that from the 10 cities in the Citarum River, Citarum watershed, the polluting load in the city of Bandung is the largest contributor of value to all pollution parameters, where the burden of this polluter is calculated from the number of people multiplied by the emission factor. Yeah, this is such like that, such like this. This is BOD 0.04 kilogram per person per day, or maybe nitrogen, total nitrogen is around 0.002 kilogram per person per day. Yeah. Okay. This is the potential pollutant in the upstream of water pollution, in the upstream of water of Citarum River. This is Majalaya area. Yes, this is from textile, and this is, and also in the Ranca Ekek, in is the Sorten Bandung, yeah, and also Banjaran and Cimahi. This is the source of imported, the source of pollutant industrial. Yeah. Okay. This is
Dr. Eko, you have 3 more minutes.
Okay, thank you. Yes, I will. Yeah, this is also the pollutants in the surface of the lake, yeah, of the reservoir. Yeah, this is a problem. In the 1967, it's still oligotrophics, but now the condition is the hypertrophic. Yeah, so, and then this is the problem in Citarum River, but now after improvement, this is rather clean before then, before the situation. Yeah, this is waste production from the Bandung Metropolitan, and then so we inform about the water management opportunities in Citarum River Basin is the reduce the risk of flooding, build a flood forecasting system, and also improving water conservation, improving water quality, increase biodiversity and habitat diversity, increase rainwater harvesting, and also creating the green infrastructure. So this is information. This is the information of in Dayakolot. This is before this is the floods, yeah, before improvement, and this is Cienteng retention pond, yeah, to reduce the flood. And also the planning is the construction of 7 polder, ongoing finish on 2021. Yeah. This is also the flood forecasting and warning system in Citarum. The main location in this is the main location the priority location at this time is the Upper Citarum area. Yeah. Now the currently installed equipment is 13 rainfall observation station, 8 water level observation station, 5 warning posts, and 2 CCTV, and 1 is LED display. So this is a procedure of distribution of telemetry information. Okay, this is okay. Then this is the water quality, the planning. This is the water treatment plan in the Sorten Bandung, yeah, Cisirung area. This is from wastewater industry, and also the Majalaya industry. This is also the wastewater treatment, and also the Bojong Soyang wastewater treatment plant is for domestic treatment plant. This is okay. Now this is we spread the koan fish, but sometimes it's not also effective here, and also the vertical circulation to avoid the eutrophication, yeah. And also now this is the program of the Citarum water pollution, Citarum water set pollution and damage control, yeah. Namely the critical land management, industrial waste handling, livestock waste management, domestic wastewater treatment, waste management, control of space utilization, yeah, the water resources management, floating net cages arrangement, law enforcement, yeah, of course, the social is educational, public relation, and tourism. This is the vision. And also this is now there is a Citarum Harum program, yeah. Okay, now this is the Citarum Harum program. is in the 9 regencies or city in Citarum watershed has made an update on the industry. Bandung Regency is 207 industry, Sumedang Regency is 36 industry, Karawang Regency 40 industry, and also now has reported the industry data is in the Bogor Regency, Bandung Barat Regency, Purwakarta, Cianjur, Cimahi, and Bandung City. So, okay, this is Oxbow arrangement also. Yeah, the Oxbow arrangement objective is to restore water source function, also river water quality improvement, utilization of space for public activity, and then regional raw water reserves. Now, this is the Oxbow construction for flood control and raw water supply. Okay, now this is the Oxbow in Beomcheol. Before it's like this, but now this is have been improved. And this also this is so like that. Then this after is now is rather improved. Yeah. There's also Dara Ulin Oxbow conservation. This is still in planning, but and located in the Nanjung area is the largest Oxbow. It's around 2.8 kilometers long and 50 meters wide. Yeah, we hope this is can be built until 2001. So this is also the planning of the Citarum Harum programs. Yeah, West Cicambe Polder, East Cicambe Polder, Cipalasari Polder, Andir retention pond. Yeah. This is will build. Sorry, this has been built, and also Cienteng retention pond, yeah, and then Beomcheol polder also has been built, and then now is Cisangkui polder also. Yeah, this is the construction of Cisangkui floodway, yeah, and also this is the cleaning of the Cisanti situ or Cisanti Lake. Indonesian area. Yeah, this is improvement. Okay, I think this is thank you very much for your attention, and hopefully we can improve the Citarum watershed. Thank you very much. Back to
Thank
Dr.
you,
Ko.
Dr. Ko.
Yes.
So you are so passionate to provide many valuable comments for the audience, but it's good to share your knowledge and information regarding what you want to talk. Okay, let me introduce next panelist, Ms. Abdul Malik from Bapenas, who is the Director of Water Resources and Irrigation in Bapenas. So, Abdul, do you also have any presentation file, and then you can load it, and then you can use it, okay?
Thank you, Dr. Ko, my friend, and all the participants. Maybe my panels many is already been said by Dr. by Pak CEO, Pak Imam, and Pak Professor Eko, and maybe I just add something about okay, screen broadcast. Sorry. Okay, everybody see my screen sharing. So first, maybe I like to highlight what now is being done in Citarum River Basin. Actually, government try to organize the pentahelix approach to combine between academic, business, communities, media, and government into one organization, organization and chaired by the governor, and in the daily activities, the regional commander is in charge, and my role, the role of the Ministry of Planning of Bappenas, actually, we organize what we call the mini Musrenbang. Yeah, this is the meeting, annual meeting, or some occasional meeting by all relevant stakeholders to actually to try to always improve the action plan the 7 years. And since many ministries and the organization, including the state-owned company, has the approach, and as a result, this approach will have a third period. First is the planning period for the next 7 years, and what we call the long-term action plan up to 2023. And the content of the action plan consists of a comprehensive program from critical land handling, industrial wastewater treatment, farm wastewater treatment, domestic wastewater treatment, waste management, controlling floating nets also, and Citarum River Basin space utilization control, law enforcement, water quality monitoring, water resource management, and is one of the most important things, actually, always conducting education and socialization to industry and institutions and communities by using education and public relation. And we hope to increase our water quality index values. That the action plan is breakdown into more detail indicator of the outcome and the impacts. For instance, for the controlling floating nets, the output indicator, one of them is the removal, but also how to provide a job to the affected person by providing training and technical assistance in businesses. Okay, and what we now doing is also due to the COVID-19 in 2020, actually the plan is revised since a lot of impact especially in terms of the capability of the fiscal, and we actually improve our target the water quality index, but we modify the action. For instance, the revise is then try to more refine the non-structural approach of the Citarum River Basin program. For instance, try to improve the institution, the viability of the pollution prevention institution through the determination of the pollution load capacity and target water quality. And then we really try hard to lower the burden of pollution, disaster risk, fostering the application of the clean technology, through education, socialization, community involvement, as well improving research and development. And last but least, actually to improve the people well-being who work, who lives in the Citarum catchment area river basin through poverty and elevation program. And we try to improve our management of our river basin pollution by improve the information to the public and improve the supervision and enforcement of the law. So that we will 7 new strategy that complement, make a complete of the current carrying out rehabilitation and restoration. And we revise also, to make it more simple, the action plan of the indicator that the river basin. For instance, the waste management is now become more detailed, especially about the amount of the managed waste and the education and the community, like how many number the educational institution educated and communities empowered. And we also improve our target, like Pak Imam said in the opening, to improve our data information and public relation management. And we really thanks also with Dr. co-work about the Citarum flood forecasting system. And the target then being revised. This is the progress. Actually, we already achieved several milestones, like the critical land handling to 26,000 hectares has been improved, and then we provide 35,000 more domestic household, domestic wastewater treatment, and right now the capacity to manage the waste is improved to 2,700 tons per day, and to improve our industrial wastewater treatment from about 1,000 industrial built, we improve 300 of them. And to improve the farm waste treatment, half of the cows is already achieved, and the controlling the floating nets, that is one of the target also. We achieved 33,000 units, up from 141,000 we need to improve. In the water resource management and tourism, we improve our water tourist destination, and regarding the education and community empowerment, we reach 1,200 villages and 24 communities. Okay, this is one of the maybe comparison before and after, like Prof. Eko already mentioned. Also, the Situ Cisanti and then the waste management on the river is much more improved right now. And this is the portrait of the daily activities, how actually the cleaning is done at the beginning, and then how actually government, including the military, doing community participation about deforestation, and this is the maybe kind of the impact, the crash program to collect the garbage at the beginning and then improve the waste management in surrounding area. And this is several result of them: the oxbow management, the flood control, and then the oxbow management. Okay, and every year we done the evaluation. That is one of the important milestone. We need to evaluate year by year, and one of the findings actually right now, the action from the central government need to be transferred to regional government. So we need to improve our water resource conservation in the river basin organization, and also to accelerate the regional government capacity building. And we scale up the success story from one of the Situ Cisanti into another area and increase the capacity of the local government. And okay, that's all from my presentation. Thank you very much.
Thank you, Pak Abdul Malik. Pak Abdul Malik and his directorate is in charge of developing and updating national water risk management strategy and coordinating and supervising at the national level. So that's so informative to listen from your ministry side. Thank you. And our next panelist is Professor Triweko from UNPA, Parahyangan Catholic University. So Professor Triweko will talk he'll focus on fish farm issues in the Citarum and Korea. So, Triweko, do you also have some file? You can load your file for your talk.
Yeah. Okay. Thank you very much, Dr. Ko, for this opportunity for me to share my opinion, maybe related to Citarum River Basin. And good afternoon, ladies and gentlemen. This afternoon, after we are from the presentation of the CEO of PJT2, Dr. Imam Santoso, and also Professor Eko Irianto, we understand that the water pollution is a serious problem for Citarum River. And this problem is even worsened in the reservoir area due to floating cage aquaculture or the fish farm. But from the presentation from Professor Kim, we learned a lot about how Korea has removed their fish farm or floating cage from their reservoir. Therefore, this afternoon, I just want to share my view related to what kind of study or how a comprehensive study is needed for the formulation of government policies in related to floating net cage development in Indonesia. From the presentation of Dr. Imam Santoso, we understand that the problem he faced in Jatiluhur is about the heavily polluted of the water quality in Jatiluhur Reservoir, and also about the sedimentation due to feed waste reaches 82,000 tons per year from the fish feed, and also an invasion of foreign species, loss of the native fish population, and also the water quality degradation, which will fast corrosion to basins and turbines. I think beside that, we also worry about the impacts of the pollution to recreation activities in the area due to odor and also raw water uses, especially for water supply and fish mass mortality, which is also happens in that area every year, as usually about in January or February. But from the presentation of Professor Kim, this is the picture that I learned a lot, that very interesting for me, because the fish production was the major cause of eutrophication, also in Lake Soyang in Korea. And this is what we experience also in many lakes and also reservoir in Indonesia, including the reservoir of Jatiluhur. And about the history of the Lake Soyang, in the 1980s, you establishment of fish farm in Soyang, Lake Soyang, but it was removed in 1999. Yeah. So, and so my question is, when you remove the fish farm, how Korea substitute for its freshwater sources? Because this, I think, once become a serious good sources for the fish, but now when it was removed, there is no fish anymore produced from that area. Also, my second question related to this problem to Professor Kim is that is there any social problems resulting from this fish farm removal? May I share with you some of my knowledge related to the problem, cascade problem in Indonesia. From some publication, I learned that there is a growth of the fish net cage, and we call it as FCC, fish net cage culture, in several reservoirs in Indonesia. And it seems that in Juanda Reservoir especially, it is a great development of that cage. Yeah, and in this table, we show that in 2019 there is around 24,000, and from this presentation, Dr. Imam Santoso mentioned that in 2021 it has been improved, developed to 46, so almost twice. So I don't know which one is the correct, but it is still very serious. I think it's very serious problem in the number of the FCC in Jatiluhur especially. And from other publication, there is an increase in fish culture using floating net catch or FCC in several lakes also. And the development in Lake Maninjo, for example, it is from 1919 to 2008, there is the development up to 527%. And Jatiluhur Reservoir, in other words, it was called as the Waduk Juanda. Juanda is the same as with Jatiluhur. It is the highest with almost 2,000. So it's very large number of floating net kits in that area. Also, what Cirata Reservoir, it is very close to Jatiluhur. Also, the development of the number of the floating kits also very large number. About the trophic levels, the condition, the pollution level, yeah, which is showing by the eutrophic, yeah, the trophic status. We understand that the Juanda Reservoir, it is also, I think Professor Eko Irianto mentioned, it has been hyper-eutrophic, yeah. Also in Cirata, in some area also hyper-eutrophic. In Lake Maninjo is also hyper-eutrophic. So it is very dangerous condition, I think, in terms of water quality in reservoir and lakes in Indonesia. And about this showing the the carrying capacity. If we compare the carrying capacity and actual condition of floating net cages in some lakes and reservoir, again for the Jatiluhur Reservoir, it has been almost 1,918% of the capacity. So it is much more than the the plan, the design capacity. Also for Cirata, almost 600%, and also in other reservoir, Waduk Dharma Reservoir, it is in Kuningan, also in West Java. It's also the development of the floating net kits there. It's also very large, in around 600% from its capacity. Some studies has been done related with the problems of floating catch nets in Indonesia, many, and some of them related with the institutional arrangement, like this figure mentioned about how the complexity and difficulties of coordination and cooperation amongst the institution involved in this business of the floating net kits. Yeah. There is also a book about unsustainable fishery governance in Jatiluhur as reservoir. So these authors has prepared as writing a book, especially for the Jatiluhur Reservoir in 2016 in Indonesia. The title is Tata Kelola Perikanan Berkelanjutan di Waduk Jatiluhur. It means that it is how the fishery governance in Jatiluhur Reservoir will be sustainable. Yeah. So from this experience and from several literature, I learned that it is a multi-dimension problem in FCC utilization. From the technical aspect, we need FCC technology, and also how to fish feed, like Professor Kim has mentioned also. And also, I'm thinking about the comparison between FCC and what is the conventional fish pond, for example, which one is better to be implemented in order to produce fish. From the economical aspect, I think the FCC activity is very important for us for fish production, but also in regional development. From the social aspect, there's an employment opportunity for fish farmers surrounding the lakes, of course. But the environmental aspect is also very important because this activity will cause water pollution, eutrophication, and also reservoir sedimentation. And from water resources management aspect, we face with the multiple use of water and reservoir, especially for the multiple purpose reservoir like Jatiluhur, in which the problems of water pollution, as we have mentioned before, it's very, it has impact to other users. From the institutional aspect, there is institutional arrangement on water management, which is very complicated as in Indonesia. From also in fishery, really also involving the trade and environment, finance, and so on. And from the legal aspect, we need to harmonization, both in vertical and also sectoral harmonization of the regulation. So in summary, the development of FCC in lakes and reservoir in Indonesia has resulted water quality degradation, increasing eutrophication, which in turn threaten sustainability of water resources utilization. We understand that a lot of study related to the implementation of FCC in lakes and reservoir in Indonesia has been done from different perspectives. But it seems that government policies to control FCC development have not been clearly formulated. The third, to support the formulation to government policies on FCC development in Indonesia, I think a comprehensive research program is needed. And therefore, and also the success story from South Korea in controlling FCC would be a valuable lessons in formulating government policies in Indonesia. This is my opinion related with the problems, and which I focus to the problems of floating net cages development, and that we can, I hope that we can discuss in more detail and some action collaboration between Korea and Indonesia can be focused on this issue. Thank you very much.
Thank you, Professor Director. That's really precise and focused. So maybe we'll continue to that professional discussion and possible collaboration opportunity in Korea and Indonesia. That's what I like. And we are spending our session time almost, but maybe let's try to spend 10 more minutes before I'm wrapping up. So let me introduce Dr. Hong Il-pyo, who is a senior research fellow at KICT. So sorry, Dr. Hong, could you make a short comment regarding our session? Yeah.
Yep. Thank you, Dr. Ko, for your very nice moderation of this session. Also, thank you to giving me this kind of opportunity to, as a panelist for this very important cooperation with Indonesia session. Actually, I was very impressed about the, all presentations, from Dr. Imam Santoso and also the Professor Beomcheol. And I was a little surprised that the three panelists from the Indonesia side, Mr. Dr. Eko and Mr. Abdul Malik and also Professor Patreko. So their presentation was so excellent and very impressive. Actually, beginning of the presentation of Dr. Imam Santoso, it was very important for us to understand the current water resource and the pending water problems in Indonesia, including disaster and the water infrastructure. Also, Mr. Eko, it was a very nice lecture about the Citarum River Basin water case. I clearly understand the current water situation and urgent problem in Citarum, particularly for the your operation about the flood forecasting system. I'd like to thank you for your comments about the flood forecasting system. Actually, I come from, Korea Institute of Construction Technology, KICT. My colleague managed the kind of Indonesia Citarum flood forecasting system from KOICA. So I understand, my colleague is, preparing the second stage of the flooding forecasting system project from KOICA side. So I really appreciate your presentation. And Mr. Abdul Badi, your presentation was very useful and understand the governance of the stakeholder between the, the public sector and the, private sector and the residents. Also that the new action plan and the progress of implementation up to 2025. And the presentation from Professor Patrick was also so nice. So actually, I have a lot of, some questions and the comments for your presentations, but because of the, time limitation, I'm going to discuss with the kind of, the question to Dr. Goi Kwan. So, but I have, one more question. I have one request. I'd like to request to you, the three panelists from Indonesia side, to show your presentation. It was very excellent, the material of the lecture for Citarum River Basin. So if you send it, presentation to Dr. Go, he may share your presentations. Thank you very much. Once again, I'd like to appreciate your very nice presentation and also the the panelists speech. Thank you so much.
Thank you, Dr. Hong-Il Pyo. And sorry, our final panel is Professor Jung Se-Eun from Chungbuk National University. Sorry, you have been waiting for long.
Okay.
Now, could you spend a couple of minutes regarding your comment and feedback on our panel?
Okay, good afternoon, everybody. Thank you, Dr. Go, for inviting me to this informative special session. It was a good time for me to understand the Citarum River Basin watershed and also watershed management system. I want to talk a little bit about IWRM and water quality issue on dam reservoir operations. IWRM was formulated 15 years ago, but there are not many successful implementation examples. Today's keynote speech demonstrated that the dams in Citarum River Basin provide a very important functions in terms of water, energy, and food nexus. In Indonesia, as well as in Korea, multipurpose dams occupy an important part of IWRM in terms of water supply, flood control, hydropower generation, and environmental water supply. But I want to ask this question: is this functioning of these dams sustainable and environmentally sound for future generation? More than 60,000 large dams have been built and operated worldwide, and as a result, more than 50% of rivers are unable to flow naturally, and their flow is controlled by dams. One of the biggest problems with the dam reservoirs is a sedimentation problem. Globally, 1%, it's about 50 billion cubic meters of total water storage capacity annually is lost through sedimentation. This means that after 100 years, most of dam reservoirs may lose their functions. In addition, dam reservoirs are causing various environmental problems such as cold water, persistent turbidity, eutrophication, and algal bloom. Moreover, according to UNESCO IHA, dam reservoirs have been identified as important emission sources of greenhouse gases such as carbon dioxide, methane, and nitrogen oxide. The problem of fish farms and associated eutrophication in reservoirs presented today is one particular problem of this type. Then how to solve these problems? The dam reservoir water quality issue is a long-standing issue and at the same time a climate crisis issue. It is not a problem that can be easily solved in a short time. On the contrary, it could be made more worse by the effects of climate change. The fundamental solution is to reduce pollutants in the water set, and the measures to improve water quality in the lake must be taken concurrently. Water set measures are fundamental measures for water quality improvement, but are costly and time-consuming, whereas in-reservoir measures such as alarm injection are less expensive but have a temporary effect. International cooperation is an important way to solve water quality and aquatic ecology problems surrounding dam reservoirs. Among the contents presented today, K-Water's cooperation in water management information system is a good example. And Professor Beomcheol's solution to the fish farm problem can also be a good reference for solving the Indonesian problem, I think. Finally, I would like to remark this one. The role of dam is very important in the practical implementation of IWRM. But I want to address that the proactive efforts for policies, roads, institutional framework, and the technical instruments and investments must be initiated to solve the problems of sedimentation and water quality of dam reservoirs for the implementation of a sustainable IWRM in Citarum River Basin. Thank you.
Thank you, Professor Dong Seong, for your valuable comments in our final stage of our session. And may I ask Professor Beomcheol, could you answer regarding the panelist question on your presentation?
Okay, I give two answers to short questions. One was the substitute for fish production. And after removal of fish farms in the reservoirs, we imported a lot of fish from other countries, freshwater fishes and marine fishes. And now we established marine aquaculture very effectively. So now marine aquaculture is flourishing in industry in Korea. We can see a lot of floating net cages at the coast of southern and coastal area, and especially in the southern coastal area. So actually, the freshwater fish was not a main diet in Korea, so it was not a serious problem. And the second question about the social problems of removing fish farms. Of course, we had some social conflicts and debate and sue. Fish farmers sued government they wanted to extend their fish farm licenses, but because the fish farm license was expired after 10 years, so there was no any duty to extend the license for Korean government side. So the farmers lost the suit against government, and finally we removed it. So yeah, we had some small conflict between farmers and governments and citizens and environmentalists. Yeah. Okay, that's my question, answer. Yeah.
Thank you, Professor Kim. Hopefully that's answer to your question, Dr. Drieko. And before I wrap up, Dr. Imam Santoso, could you have any comments before we close our session?
Okay, thank you very much, Dr. Ko. And thank you very much for all the panelists, Professor Eko, Professor Trioko, and Dr. Abdul Malik, and also Mr. Chung and Professor Chung and Dr. Hong. We know that this floating net cage is have a complexity problem. Also, it will affect the water quality, also the economic aspect of the farmer, or the function of the dams. And I agree with Mr. Triweko said that it is need to formulate a government policy to floating net cakes to find the comprehensive formula that need a comprehensive research program is needed. It may become from the Korean side and Indonesian side, so we can sit together to have some solution to give the alternative program to the governments how to solve this problem, especially in Indonesia, because in Korea, as Dr. Kim said, you have a successful program that can be adopted in Indonesia. Maybe some of this program can be adopted in Indonesia. It's very important for us. This is my comment, Dr. Ko. Thank you very much.
Thank you, Dr. Imam Santoso. In our session, we have so valuable and informative discussion and knowledge sharing, and we realize that the role and responsibility of Jatiluhur multiple dams and reservoirs in terms of national level food security, energy, and water security. But still, we still have many challenges we should overcome by working together. That including fish farm issues and also integrate water supply and water quality management for the Citarum Basin. And the other axis is basin-wide flood management by extending the developed flood forecasting and warning system for Bantung Basin. That should be extended to the downstream of the Citarum Basin. We'll work for that. So we are almost ready to initiate the project. But on the other side, I really want to develop and mobilize another collaboration project with Jatiluhur and Beomcheol together for water quality and water supply management technology development and application. So although we close our session this afternoon, but we'll continue our discussion and dialogue between water export in Indonesia and Korea for the next year forum, and we'll continue until we can satisfy our farmers and citizens in our basin, let them make happy with water. Terima kasih banyak. Thank you. Bye-bye now.
Kamsahamnida.
Kamsahamnida, Dr. Ko, and everybody, all panelists and
Thanks
all speakers.
everybody. Thank you very much.
Thank you very much.
Thank you.
Pak Malik sehat-sehat.
Terima kasih.
Sehat, Pak.
Kamsahamnida.
Kamsahamnida.
Kamsahamnida. Thank you
Bye.
very much.
Thank you.